When it comes to natural disasters, few capture our attention quite like volcanic eruptions. And if you're anything like me, you may have found yourself wondering about the slumbering giant beneath Yellowstone National Park. Could it blow and bury parts of 3 states under ash? Or worse, trigger a global catastrophe? Well, fear not, because a new study has just put those doomsday fears to rest for now. They captured the clearest, most detailed look yet at Yellowstone's underground magma chamber, and the results are reassuring. So let's dig into this super cool science together and find out what they discovered. Yellowstone National Park is famous for its geothermal wonders, bison, and of course, its supervolcano. But here's a fun fact. Did you know that it also hosts the world's largest living organism? A giant colony of quaking aspen trees that are all connected by a single root system. Kind of like one big happy family. The Yellowstone supervolcano has had 3 major eruptions in the past, 2,013,000 and 640,000 years ago, leaving behind a massive caldera that's now home to the park's upper geyser basin. But the question on everyone's mind is, when will the next eruption occur? Now listen up. Scientists believe that there's a magma chamber about 6 miles beneath the park's eastern flank. It's like a giant underground pot of molten rock that could one day turn Yellowstone into a real-life version of Mount St. Helens or even Krakatoa. But just how much molten material is down there? That's where the new research comes in. In the past, scientists have used various methods to estimate the magma chamber's size. For example, they've studied gravity changes, seismic waves, and even the patterns of light and heat escaping from vents on the ground. But these techniques only give us a rough idea. It's like trying to figure out how much water's in an ocean by counting the waves on the surface. You can get a general sense, but it's not very precise. So what did this latest study do differently? Well, instead of relying on indirect clues, scientists actually took a direct look at the magma chamber using a technique called receiver function analysis. Here's how it works. First, they recorded seismic waves generated by small earthquakes that happened around Yellowstone between 2009 and 2018. Then they analyzed the waves as they pass through the Earth's crust. Think of it like listening to the echoes of tiny rumblings under the ground. Now, here's the thing. Seismic waves travel differently through different materials. They're faster in solid rock and slower in liquid magma. By studying how the waves were affected as they moved through the Earth, scientists could identify areas where the rock had turned to liquid. This allowed them to create a detailed map of the magma chamber showing its size, shape, and location. And what they found was pretty fascinating. First off, the magma chamber isn't a neatly confined blob. Instead, it's more like a thick layer of partially molten rock stretching from just east of the Continental Divide to the park's eastern border. It's roughly 23 miles long, 12 miles wide, and almost 3 miles deep. What's really cool is that this technique gave scientists a lot more information than previous methods. Like they found that the magma chamber is made up of 2 separate pockets, a larger lower chamber and a smaller upper one connected by a narrow channel. But that's not all. They also learned that the magma isn't evenly distributed within the chamber. There are areas with varying degrees of melt, ranging from less than 5% to almost 70%. And here's the most important part. The total amount of molten material in the chamber is pretty small, just about 4 cubic miles. To put that in perspective, that's enough to fill up the entire Grand Canyon. But compared to the sheer volume of rock in Yellowstone's crust, it's just a tiny drop in the bucket. Now, you might be thinking, big deal, I've seen bigger drops of water. But here's why this is significant. Scientists use magma chamber size and shape to predict volcanic eruptions. If the chamber fills up, pressure builds up, and eventually the volcano erupts. Knowing how quickly the chamber is filling helps scientists gauge the risk of an eruption. And here's where things get interesting. The last magma estimate from 2006 suggested that Yellowstone was filling up fast, but the new study shows that the rate of magma generation has actually decreased since then. The magma chamber isn't getting any bigger, which means that the risk of a large eruption in the near future is lower than we thought. But wait, there's more. Scientists also looked at another key indicator of volcanic activity: the release of gases from the magma chamber. When magma heats up, it releases gases like water vapor, carbon dioxide, and sulfur dioxide. If these gases build up, they can trigger an eruption. So scientists monitor them closely. To measure gas release, they analyze gas samples collected from various locations in the Yellowstone region, including the summit of Steamboat Mountain, the Northeast Molar Geyser, and the Norris Geyser Basin. By studying the chemical composition and amount of gases released, scientists can determine if there's a change in volcanic activity. And guess what? The data shows that the amount of sulfur dioxide released from Yellowstone's vents has been decreasing over time, indicating a calmer magma chamber. In simpler terms, the new study suggests that Yellowstone is kind of chill right now. But don't worry. That doesn't mean scientists are going to relax. They'll keep monitoring the volcano because, remember, predicting volcanic eruptions is like trying to forecast the weather. You need as much data as possible. So for now, let's appreciate the incredible science that allows us to peek into the fiery depths of our planet. Now, I want to hear from you. What do you think about this new research? Does it ease your worries or make you want to learn more about Yellowstone? Leave your thoughts in the comments below. And don't forget to hit the subscribe button so you never miss out on our exciting journeys into the world of science and technology. And hey, if you're still hungry for knowledge, why not check out some of our other videos? We've got everything from space exploration to artificial intelligence and everything in between. Who knows? You might just learn something that blows your mind. Now here's a fun fact that I bet you didn't know. Did you know that the ancient Greeks believed that volcanoes were the home of the gods? They thought that the rumbling and fire were the gods talking and making their presence known. I guess it makes sense when you consider that, before modern times, people didn't really understand how volcanoes worked. They were just really scary and unpredictable. So it's not surprising that people would imagine them being caused by the supernatural. Speaking of volcanoes, did you know that the largest active volcano in the world is Mauna Loa in Hawaii? It's a shield volcano, which is a type of volcano that's known for its broad, gently sloping sides. Unlike the tall, pointy stratovolcanoes that you might picture when you think of a volcano, shield volcanoes are formed by the accumulation of fluid lava flows that spread out over large areas. And Mauna Loa is the king of them all. It rises nearly 13,000 feet above sea level and covers an area of more than 2,000 square miles. That's about the size of Los Angeles. But it's not just the size of the volcano that's impressive. The amount of lava it's produced is also staggering. During its most recent eruption in 1950, Mauna Loa released over 240 cubic miles of lava. That's enough to cover the entire state of Connecticut. And it gets even crazier. One of the largest eruptions in recorded history occurred in 1887, when Mauna Loa unleashed more than 1,000 cubic miles of lava. That's nearly 40 times the volume of Mount St. Helens, the volcano that devastated the Pacific Northwest in 1980. Now you might be wondering why I'm telling you all this. Well, for one, I just think it's really cool to know about these amazing natural phenomena that exist all around us. But I also wanted to highlight the fact that not all volcanoes are created equal. They come in all shapes, sizes, and levels of danger. And while we should definitely respect their power, we shouldn't fear them unnecessarily. For example, Mauna Loa is considered to be one of the most dangerous volcanoes in the world, but it hasn't erupted in over 50 years. On the other hand, Mount Vesuvius, which destroyed the Roman city of Pompeii in 79 AD, is considered to be one of the most historically significant volcanoes, but it's also been dormant for 1,500 years. That's why it's important for us to learn about volcanoes, track their activity, and take the necessary precautions to protect ourselves and our communities. And that's exactly what scientists are doing at Yellowstone National Park. They're constantly monitoring the volcano's activity, collecting data, and sharing their findings with the public. Of course, it's impossible to predict when or how a volcano will erupt, but by learning more about them, we can better understand the risks and prepare accordingly. So the next time you hear about a volcano, whether it's in the news or in a story, remember that they're not just dangerous and scary. They're also fascinating natural wonders that have shaped our planet and inspired our imaginations for centuries. Now I want to leave you with one final thought. The world is full of mysteries, and Yellowstone National Park is no exception. While we may never fully understand the forces that shape our planet, we can always appreciate the beauty and wonder of the natural world around us. So the next time you visit Yellowstone, take a moment to look up at the mountains, feel the wind in your hair, and remember that you're standing on hallowed ground. Thanks for joining us on this journey to Yellowstone National Park. If you enjoyed this video, be sure to hit the like button and share it with your friends. And don't forget to subscribe so you never miss out on our exciting adventures. Until next time, keep exploring and stay curious.